Well, let's look at graphing sine and cosine functions. And these are the things I'm going to do on this video. First, looking at the different types of graphs. They match each other, but it's good to see the different x values we can use. We'll do a basic equation setup, the 4 different parts of a trigonometric function. And we'll graph the parent function of y equals, or function of x equals sine of x. And the x is actually, of course, the angle. So it could sometimes be theta or something like that. And oftentimes it still uses x because we think of x and y. We'll also talk about transformations to the functions and graph one of those transformations, or a function that has a couple of transformations. So I want to start with the type of graph. Well, let me find an example of one here. Here are 3 types of graphs, really the kinds that we would use. So I put they match at the bottom of this because they do. You're used to a normal line, and here's the y values. I just didn't do them much here, but we wouldn't go more than 1, 2, or 3 anyway. But we could go out 1, 2, 3, 4, 5, 6. Well, if you think about what pi is, that it's 3.14, it's going to be just a little bit past 3. So it's going to be about there, 3.14, give or take. And then that means that pi over 2 is a little bit more than 1.5. So this is about halfway between 1 and 2. And same 3 pi over 2 fits in about here, 4 point something, and 2 pi is 6.28, so a little bit more than 6. So rather than use 1 through 6, we are able to use radians. We can also use degrees. And so, of course, pi over 2 would match the 90, and 180, and so on. All of these are appropriate ways to graph a function. Oftentimes, we only see this. But if you remember that pi is 3.14, you can note that it's here, and then that 180 degrees is here, and that 90 degrees, or pi over 2, is about here. And that right over here, about there, would be 2 pi. So remembering that pi as 3.14 is actually still a number that we can estimate, at least on these lines, helps you with that. So we will be graphing mostly using this right now. But for people who would prefer to put them in degrees, you can just write degrees underneath on the graphs that we use. All right, let's put that aside. So the next thing is to talk about the basic equation setup. All right, so here's what the basic equation setup looks like. And actually, to do this, I think it would be good to do a little bit of a graph. So I'm going to show here the basic sine graph. We'll graph it again in a moment with real detail, but I'm going to show. I think I'll go up, I guess I'll go 1, 2, -1, -2. But over here, I think I want to make this 2 pi. We'll do this in radians. So about halfway would be pi. Halfway between that would be pi over 2. And here is 3 pi over 2. The sine curve has points here. Looks like I'm going to go right through the line. So it looks like this. I'll show you how to figure those out in a couple of moments. There's the basic sine curve. That is y equals sine, whoops, put the x a little too quickly, y equals sine x. Now, the actual real equation is y equals a sine bx minus c plus d. Each one of these things has a specific purpose. Right here you see sine of x, and there's nothing else in these other spots. This is the basic parent function. So I'll even write that over here, parent function. Because all the other transformations come from this. You do something to it. What the a does, and I'm going to draw that over here and write the word amplitude. We take the absolute value of that number, that means it could be negative or positive, it wouldn't matter. That is how far up you can go from the basic line. Notice that this thing curves over the x-axis. So that's a baseline right in the middle. Call it the middle line if you wish to. The amplitude is how far up you go and how far down you go from that, at the highest point or the lowest point. Well, in this one, there's a 1 there. That means you go up 1 and down 1 at the highest and lowest points. And that makes sense when you look at this. If this is the baseline, here is the highest point on that curve. And when we keep going, we go up to that same 1. And it's a distance of 1. And then going down is a distance of 1 also. Now the B is used to get the period for finding the period. And the period is 1 full rotation of it. So if we're coming this way, I have the arrow going out because we could go that way. Let's say we're coming this way. We pass 0 here, we come up to here, we pass y equals 0 again, but it's going the other direction than it was here. When we come back, now it's sort of like we're going to start repeating it. This is the place we're going to start repeating it. Therefore, from here to here is 1 full period. And it's a distance of 2 pi. The way you figure it out is that there's a little formula. By the way, we could call it 1 full cycle. I'll put the word full here. 1 full cycle. That's another way to think about it. And the way you figure out is a little formula. Period equals 2 pi over b. So whatever number b is, in this case there's a 1 in front of the x. That coefficient you put here, and 2 pi over 1, in this case equals 2 pi, which indeed is what we see. The c is used for the phase shift. Now, let's talk about phase shift and vertical shift at the same time, because this is something you will be familiar with. The phase shift tells you how far you're going to the left or the right, and the vertical shift how far up or down. That's the same thing whether it was conics or parabolas or whatever it was. You would use this, the x or h or k, to tell you actually h, moving one way or the other this way. And the k on the outside, such as for a parabola, will move you up or down. It's the same concept here. So to find the phase shift, though, is not just the c. It's not just that. It's this divided by that. So if this is 1, that's great. If it's not, you have to divide by it so that your period and the phase shift are working together. The vertical shift is much easier. You don't have to worry about any little formula or anything else. It's just up or down. So if this was, say, +2, we would move everything up 2. This point would go up 2, this point would go up 2, all the little points in here would go up 2, and the curve would go like that. If it was -2, everything would come down 2, and the curve would go like that. So there's the basic equation, and each one of these things are here. Now you're going to have to determine each one of these things. So we're going to do that on some of these. Let's come over here. And for the third thing we're going to do, that's going to be to graph 2 periods of y equals sine x. Now I showed you already what it looks like, but you need to actually be able to identify or do something like this yourself. So let me show you how to figure it out. I have an xy table here. Doesn't look quite like an xy table, but it actually is. So you're used to xy tables looking like this for the most part. Some people like doing them this way. Perfectly fine. You have to get used to doing it this way for these. I guess it could be done this way, but it's a little more complicated in my mind. Just I don't think that way. And remember that x is also the angle. So what we're going to do here is we're going to say y equals sine of each one of these. So this one would be sine of 0. This one will be the sine of pi over 2. And this one will be the sine of pi. And that'll be the sine of 3 pi over 2. And you get the idea. We will put each of these in here. And now you need to know what the sine of 0 is, and the sine of pi over 2, and the sine of pi. Of course, you remember them perfectly, because you know your unit circle. They're all on the unit circle, and you know your unit circle. So let's use it. The sine of 0 degrees, or 0 pi, which is the same as 2 pi anyway, one full time around or at the beginning, the sine is 0. So y equals sine 0 is 0. So that means that when the x value here, when the angle is 0, the y value is 0. Now for pi over 2, on the unit circle you can see that at pi over 2, the y value, or sine, is 1. So that means that when we're at pi over 2, we can go and put a point at pi over 2 and 1. When at the sine of pi, we're back to 0 for the sine, so we're back to here. At 3 pi over 2, the sine, or the y value, is negative 1. So that means at 3 pi over 2, we have to come down here to negative 1. And at 2 pi, it's back to 0. Not one of my strongest things, but ooh, I made this one look pretty good today. All right. Oh, it's 2 periods. Well, you continue the same thing, because if that's pi over 2, pi 3, pi over 2, this is pi over 2, pi 3, pi over 2. It's just one more time around the unit circle. So that means I'll go up to 1, 0, down to negative 1 and 0, and I can continue. So not quite so good a curve, but okay. We could also go back the other way, because negative pi over 2 would be going to like 3 pi over 2, and then we're at pi, so this curve continues in the same way. Right? And if I were to keep it going there. So from here to here, I have graphed 2 periods of sine x. Now, oh, and I forgot, we need to identify these things. So remember that what we're looking for is y equals a sine bx, I guess it's this one, bx minus c, and then plus d. So the amplitude is the absolute value of the coefficient here, which is just 1. Oh, the vertical shift. So now the vertical shift, I've got these out of order, so the vertical shift, we have to go to here, and there's no plus or minus of anything, so we're not shifting up or down at all, so it's 0 for the vertical shift. The period, well, there's a 1 here. The period, remember, is 2 pi over b, and b is 1, so that means 2 pi over 1 is 2 pi. The phase shift is whatever c is, but there isn't any. There's no plus or minus anything to divide by the b, so therefore the phase shift is 0. Right? Yeah, okay, phase shift is 0. We're not doing a phase shift, so no phase shift. All right, great. All right, there we have graphed this, and you can see how to figure out each one of these using A, B, C, and D. So this one used A, this one used D, this one used B, and this one used C. So someday maybe I'll rearrange those, but it does make sure you know what you're reading and pay attention to it. All right, so I'm going to put that one aside, and we are going to talk about the transformations again. All right, so let's take this one. Y equals 4 cosine 2x minus pi. All right, now, oh, I guess I should put something here. I'm going to put plus 1. Okay. So I'm going to say, I want to find the 4 things, amplitude. So absolute value of A. Well, that means that's the absolute value of 4, so the answer is just 4. Period. The period is 2 pi over b. Well, that's 2 pi over, this is what's in the b position. In fact, I'll write these out. A, B, C, D. Okay? And then that's 2 pi over 2. That means the period is pi. What that's going to mean is it's going to be compressed into a smaller thing. Now, then let's go, oh, hold on here. here. Phase shift and vertical shift. The phase shift is C over B. So the C, remember that's minus, if that's minus, then that's minus a positive pi. Okay, so it has to be minus C, so that means we're going to use positive pi. So the phase shift, is going to be pi over 2. Oh, now that's a 90-degree change. That means it's positive, so it's going to move it over this way, 90 degrees. Phase shift is up here, and we use the same sign for this one, so it's positive 1, and it's going up 1. So the phase shift is a positive 1. All right. So if we were going to graph this, well, it's going to be a difficult one. We need to figure out how to graph this and how the numbers will come out. I actually hadn't planned on graphing this one, but it might be an interesting one to do. Okay, I have this one set up. I think I'll do that one afterwards. Let's look at this. Graph 2 periods of y equals sine x minus 1. I already had this one set up to do, so let's do this. Well, we're going to do this just like it did the other one. There are 2 changes here, this one and this one. In fact, let's do these. The amplitude is the absolute value of A. The vertical shift up and down is at the end, minus 1. The period, 2 pi over b, and b is the coefficient of the x, and that's a 1, so that means it's 2 pi. The phase shift is here. It should be that it would be sine x minus c, and then the minus 1's on the outside here. But there is no minus c. There's nothing adding or subtracting that's just with the x in parentheses. It would have to be in parentheses. If it's not, this one makes it the vertical shift. So there isn't anything there. That means we have no phase shift. So that information's finished there. We know from the amplitude that means we're going to be going up and down, and then everything's going down 1. But we're going to use these points to help us figure out where to put things. So for 0, we're going to put a 0 in there. 3 sine 0 minus 1. And on the unit circle, once again, the sign of 0 is 0. So what this is 3 times 0. So sine of 0 is 0, minus 1. 3 times 0 is 0. Take away 1, we're at minus 1. So when the x value is 0, we're actually here. Next, pi over 2. So what this is, I think I'll start it up here and then work it down here. 3 sine pi over 2 minus 1. Well, the sign at pi over 2 is a positive 1. So that's 3 times 1 minus 1. That's 3 take away 1. That's 2. Oh, interesting. Okay, so at pi over 2, we need to put a dot up here at positive 2. Interesting. Now pi. I'm going to do 3 sine pi minus 1. So sine of pi is negative 1. So I guess I have enough room here. Minus 1 minus 1. That's negative 3 take away 1. That's negative 4. So negative 4. So at pi, we're way down here at negative 4. Now, that looks like it's going to be an interesting curve. At 3 pi over 2, well, 3 sine 3 pi over 2 minus 1, that's 3. 3 pi over 2, the sign is, wait a second. Oops, I made a mistake. Okay, let's fix my mistake. I jumped ahead to 3 pi over 2 and put that minus 1 in here, where pi over 2 sign is actually 0. So that's a 0, that's a 0, that's a 0, and that means 3 pi, 0 take away 1. I forgot to take away 1 too. So it's actually at minus 1 here, and that point doesn't exist. At 3 pi over 2, that's where it's minus 1. At 270 degrees, the sign is negative 1. And minus 1. So there's negative 3 minus 1, or negative 4. Now we get that negative 4. So it really did exist, but it was here. So it looks like it's going to be this. So that's a little more normal for this curve. This is 3 sine 2 pi minus 1, which is 3. The sine at 2 pi is 0. And so we're at minus 1 again. So these dots almost look like they're scattered, but you know that there was a curve originally. The original cosine curve actually looks like this. Oops, wait a minute, I think I went too far. No, I didn't. Yeah, that's the cosine curve, and then it keeps going like that. The sine curve starts here and made a curve that way. The cosine curve actually is sort of like just moved over from that. So we're sort of in that sine and cosine are similar but in different places. Well, here what's happened is it's been moved up and down and changed based on those numbers, so that now what we have is this kind of curve. Oh, wait a minute. I did cosine, it's supposed to be sine. Let me do the sine again in a moment. Okay, now I would keep on going. That's that one. And then this one was down to here, and this one was down to here. And for 2 pi, I need to come back up to about there. So here is one thing. So I shouldn't have drawn the cosine, I should have drawn the sine curve, which is what this one's matching. I'll do that one, sort of a weird dashed one. So paying attention to that one, aha, I can do it in blue. All right, now notice this. Here is the original sine curve. It's been stretched. Well, actually, first it's been moved down. Instead of following that line, it's following this line here. And then it's been stretched out. Those are the two things that this that does to it. The minus 1 moved it all down 1, and then the 3 stretched it out so that it's going up 3 and down 3 instead of just up 1 and down 1. All right, so that shows how to get these. It shows what it results in with those two changes, because these two are normal from the parent function too. It also shows here how to substitute the sine values so you can calculate it, and to be careful, because you notice here I looked at the wrong one, or actually I just thought in my head the wrong one, and I have to be more careful than that. But I got the others right, and the graph shows that it's good too. All right. Now, let's put that away, and I'm going to try this other one. Let's do the 4 cosine 2x minus pi 1. And I'll do that. I got a blue one here, so I'll do that in this. Now the cosine curve, that's what I started to shown you before, and now I will show it again, because I think I owe that to you here. Here's the basic cosine curve. And then it will continue. We'll do a second one of it. And it would go backwards as well. That's just like the sine curve, but the sine curve starts here and goes this way. It's sort of like here's where the sine curve starts, but it moves over. So the cosine curve is the sine curve that's been moved a little bit, moved back. They're the same with each other, except they're a pi over 2 period or phase shift difference. Yeah, they've been shifted differently. So the amplitude is the absolute value of A. The vertical shift at the end, there isn't one. There's nothing adding or subtracting, so we're not going to be shifting it up or down. The period is 2 pi over, aha, there is a 2 here, so we put that 2 there, that's the B. Right. A, B, C, and there's no D. So that means the 2's cancel out and the period is pi. The phase shift is C over B. Well, the C is pi, and the B is 2. So that means it's pi over 2. And remember, that was a negative, positive pi, so we'll use a positive pi in there. If that had been a plus pi, it would have been a negative pi, so we would have used a negative, but it's not. So now we're going to put in the values. 4 cosine 2x minus pi. Well, we're going to put a 0 in here. So what we're going to get is 4, the cosine of, aha. Now, let's talk about how to do this here. Cosine 2, 0 minus pi. Well, I put the angle 0 in here, but I can't find the cosine of 0 because all of this will change the angle. 2 times 0 is 0, and 0 minus pi is negative pi. So what we're actually looking for is the cosine of negative pi. So let's take the unit circle and think about what that means. Here's pi, here's 2 pi, all the others. Well, if I start here, the negative pi means that I go opposite, negative this way, and I go the distance of pi. So I get to here. So the cosine of negative pi just happens to be the same as the cosine of pi, and the cosine is negative 1. So that's 4 times negative 1, so I'm going to put a negative 1 here. Oh, negative 4. 4 times that is a negative 4. I was thinking negative 4 in my head, and I said the wrong thing. Now I got it right. Now let's do this one, and I'll take some space down here for that. 4 cosine 2 pi over 2 minus pi. So that's 4 cosine. Well, the 2's cancel out, and we have pi take away pi, and so that's 0. And the cosine at 0 is a positive 1. So cosine of 0 is 1. 4 times 1 is 4. Set 4, I'm thinking 4, I'm writing a 4. Right. So if I'm graphing that right now, I'm at 0, and I go down to negative 4. I'm at pi over 2, and I'm up at 4. Okay, now let's do pi here. All right. And so that one I'm going to do over here. 4 cosine 2 pi minus pi. 4 cosine 2 pi take away pi is 1 pi. And the cosine of pi is negative 1, so that's 4 times negative 1, so that's a negative 4. Okay, now this one, I guess I can do that one over here. 4 cosine 2 times 3 pi over 2 minus pi, all right? The 2's cancel out, so I have 4 cosine 3 pi minus pi, which is 4 cosine 2 pi. And 2 pi is the same as at 0, so the cosine there is a positive 1. Oops, I shouldn't write cosine of that, I should write 4 times 1, and so that's a 4. Negative 4, 4, negative 4, 4. I think we're going to see the same thing here, because if I put 2 pi in here, well, that's what, oh, in fact, it's 4 pi, so let's go ahead and do it. So for this one, 4 cosine 2 pi minus pi. Well, here, when I work that out now, that's 4 pi minus pi, 4 cosine 3 pi. Well, 3 pi is just going around 3 times, or actually, from here to here is 1 pi. This is 2 pi, this is 3 pi, we're just right back there. And the cosine is negative 1. So that's 4 times negative 1, which is negative 4. So what we have here, the negative 4 at pi down to negative 4. At 3 pi over 2, we're up to 4. And at 2 pi, we're down to negative 4. And the in-between ones, whoa, well, I didn't draw that quite right, but I should make it so it's more of a curve. Well, now that's an interesting one. Okay. Whew, looks like a big M, but it's going to continue. If I were to continue it this way, it's going up like this and then coming down like that. And you see it's this curve that's been moved over. This thing moved it over by pi, so everything moved over, but also got compressed. So I guess it got compressed and then moved over. I'm not sure which one comes first there. easier for me to think of as compressing it and then moving it. And it's way up there like that, whoosh, up. So the 4s, instead of the 1s like that, it's been really pulled apart. Interesting one to look at. Well, that is what you do when you have the transformations of it. So let's go back to all the things we did. This one shows a change in the amplitude, a change in the period, and a change in the phase shift. And by plotting the points in the way that I showed here, using unit circle values, you're able to determine where the points go and make the approximate graph. We did that with this one, where it was determine the points by plugging in the correct values from the unit circle, and then able to make the approximate curve and able to identify each of those 4 transformation things. All right, this is a reminder one. This is the one that we did, and I had just done that to show how to get to it. And let's see, what else did I do here with you on this? And we did 2 periods of the basic graph, and you definitely want to remember the basic format and what each of the 4 things are. All right. Thank you for watching, and hopefully that was helpful for understanding how to do graphing of the sine and cosine functions and transformations of those functions.